The room wasn't loud when it happened. There was no shouting, no raised voices, no sharp exchange that people would later quote. In fact, everything sounded almost polite. Just one sentence, delivered calmly, confidently, without hesitation. And the moment it landed, something strange happened. An entire room of experts stopped breathing, not because they were offended, not because anyone felt attacked, but because when someone with unquestioned authority dismisses you in public, they don't need to be aggressive. They don't need to explain themselves. They don't even need to be unkind. Certainty does all the damage for them. It's the kind of certainty that comes from decades of validation, from institutions that echo your conclusions, from a career spent being proven right so often that doubt stops visiting altogether. That was the certainty in the room, and it pressed down on everyone watching. No one leaned forward, no one interrupted, no one thought to defend the man at the podium, because no one believed he needed defending. The Filipino man standing there didn't look like someone about to challenge an entire field. He didn't wear authority the way the others did. No tailored suit, no polished slides filled with equations, no introduction heavy with credentials. He stood calmly, hands steady, expression unreadable. To the people in that hall he looked out of place. Not wrong, not offensive, just irrelevant. A cultural footnote in a room designed for the future. Every unspoken assumption in the space reached the same conclusion. He didn't belong here, and whatever he was about to say wouldn't matter. They had already decided. And that was the mistake, because while no one in that hall believed the Filipino man knew what he was doing, what they didn't realize was that they were watching the opening moment of their own correction. Not a loud one, not a dramatic one, but a quiet unraveling, one that would leave an entire discipline rethinking what it meant to truly understand the sea. When the final presentation slot was announced, most people barely looked up. Pens kept moving, laptops stayed open. A few attendees checked their phones, already drifting toward lunch plans and side conversations. This slot had been mentally categorized before it began. A small delegation from Southeast Asia walked toward the stage. No entourage, no visible security, no air of importance. At the front was a man in his early 40s, average height, lean build, hands rough and weathered, the kind shaped by repetition and resistance rather than keyboards and conference rooms. He wasn't wearing a suit. There were no designer frames, no polished shoes, no subtle signals of institutional authority. And there were no slides waiting on the screen behind him. No equations, no flow simulations, no colorful renderings of futuristic hulls. Instead, beside him sat a scale model of a vessel that looked outdated, almost out of time. A narrow central hull, stabilizing arms extending outward, natural materials where composites were expected, lashed joints where welds and bolts should have been. It looked like something carried forward from another century. Whispers began to ripple through the rows. Not loud, not malicious. The kind of murmurs that happen when expectations quietly collapse. Some exchanged looks. Others smiled politely, the kind of smile reserved for presentations you endure rather than engage with. This, it seemed, was not a technical briefing. This was a cultural presentation, a historical aside, an intermission before the serious work resumed. The man stepped behind the podium and adjusted the microphone. No hesitation, no visible nerves. Today I will present a different approach to stability and wave management, he said evenly. A few heads tilted. Based on traditional maritime construction refined through generations of ocean travel. The sentence hung there for a moment. Then came a soft chuckle. It spread slowly, lightly like a reaction people didn't mean to share out loud. Then someone laughed a little harder, and suddenly the room understood exactly what this presentation was expected to be. Harmless, interesting, and ultimately, forgettable. When the final presentation slot was announced, most people barely looked up. The room had already moved on in their minds. Pens kept writing. Screens stayed open. A few attendees shifted in their seats, glancing at schedules, calculating how much time remained before lunch. This slot had been silently classified. Low priority. Low expectation. A small delegation from Southeast Asia began walking towards the stage. They didn't arrive with urgency. They didn't announce themselves. No entourage, no visual markers of prestige. At the front was a man in his early 40s, average height, lean build, hands rough and calloused, shaped by years of work that didn't happen. Behind a desk, the kind of hands you notice only when you're trained to look for polish. He wasn't wearing a suit, no tailored jacket, no institutional badge, no subtle signals that said authority. Behind him, there were no slides waiting to appear, no equations, no simulations, no glossy renderings of futuristic hulls floating in digital oceans. Instead, beside him sat a scale model of a vessel that immediately drew quiet judgment. It looked outdated. A narrow main hull, stabilizing arms extending outward, natural materials where composites were expected, lashed joints where welds and bolts should have been. To trained eyes in that room, it didn't look innovative. It looked inherited. Whispers moved through the rows. Not loud, not cruel. The kind of whispers that carry assumption, not curiosity. Some leaned toward their neighbors. Some raised eyebrows. Others smiled politely, the professional smile reserved for presentations you sit through rather than listen to. It was already being framed. This wasn't a technical briefing. This wasn't cutting-edge research. This was a cultural presentation, a historical curiosity. A brief pause before the summit returned to serious work. The man reached the podium and adjusted the microphone. He didn't rush. He didn't fidget. Today I will present a different approach to stability and wave management, he said calmly. A few heads tilted. Based on traditional maritime construction refined through generations of ocean travel. The sentence settled into the room. For a moment, there was silence. Then a soft chuckle surfaced from somewhere near the middle rows. Not sharp, not hostile, almost reflexive. Then someone laughed a little louder. And just like that, the tone was set. The room had decided what this was, and more importantly, what it wasn't. Commander Holstrom leaned forward in his seat. For a moment he didn't speak. Then he laughed. Not loudly, not sharply. The kind of laugh that slips out when something feels unnecessary to address. Not cruel, not mocking, just certain. He stood slowly, adjusting his jacket as he did, the movement drawing every eye in the room. When someone like Holstrom rises, people instinctively stop whatever they're doing. With respect, he said evenly, his voice carrying without effort. This summit is about modern naval engineering. He turned slightly and gestured toward the scale model beside the podium. What you've brought here is historically interesting, he continued. It has cultural value, educational value. A pause. But we're here to discuss optimized hull geometries, predictive simulations, and advanced composite materials. He took a step closer to the model, studying it like an artifact rather than a proposal. Traditional boats existed because their builders lacked the tools to calculate stability accurately, he said. The narrow hulls, the outriggers, the flexible joints. He looked back at the room. They are solutions born from limitation. What you're showing compensates for missing mathematics. No one spoke. No one shifted. The silence wasn't uncomfortable, it was affirming. Holstrom continued, unhurried. We don't guess anymore, he said. We don't rely on intuition or repetition. We model. We test. We optimize. Each word landed with the confidence of something proven 1,000 times over. He turned back to the podium one last time and lifted a finger, pointing calmly at the vessel. "This," he said, "belongs in a museum." And just like that, the judgment was complete. No debate, no discussion. The room had been told what mattered and what didn't. The man on stage didn't interrupt. He didn't raise his voice, didn't rush to explain, didn't try to correct a single assumption. He simply stood there, still, listening, because he had heard this before. In lecture halls, where credentials mattered more than outcomes, in conferences where tradition was treated like nostalgia, in boardrooms where experience without data was dismissed as instinct, he had learned long ago that arguing rarely changes minds already convinced of their superiority. What no one in that room understood was where his knowledge came from. Not from simulations running safely on screens, not from equations solved in controlled environments. His understanding came from storms, from open water when there was nowhere to hide, from seas that split steel hulls open like paper, from typhoons that erased coastlines and rewrote maps, from vessels that survived not because they resisted the ocean's force, but because they learned how to move with it. He waited until Holstrom finished, until the silence settled. Then he spoke. "I agree with you," he said quietly. The words landed gently, but unexpectedly. Modern engineering has achieved extraordinary things. A pause followed, long enough for the room to realize this wasn't a rebuttal. But there may be principles learned through direct experience, he continued, that our models don't yet measure. A few people shifted in their seats, not uncomfortable, just uncertain. "Perhaps," he said, steady and calm. Instead of debating theory, he looked out at the room. "We let the ocean decide." And for the first time since he'd taken the stage, no one smiled. Holstrom raised an eyebrow. Not in surprise, in curiosity. "You're suggesting a demonstration," he said slowly. The man nodded. "Yes," he replied. "A real-world test." He spoke without emphasis, as if the idea itself required no persuasion. "Identical parameters," he continued. "Independent judges. Open water. No qualifiers, no escape routes. Let the designs speak for themselves." The sentence hung in the air. For a moment, no one moved. This wasn't how these discussions usually ended. There were normally panels, white papers, peer reviews, not challenges. Then Holstrom smiled. Not dismissively. The smile of someone confident enough to accept a contest he believed he couldn't lose. "Very well," he said at last. "When science prevails, I trust you'll accept that tradition has its limits." He sat back down, already certain of the outcome. The organizers didn't hesitate. They understood what had just happened. This was no longer a presentation. It was a confrontation. Logistics were discussed, parameters defined, judges selected. What began as a footnote had become the main event. A year later, neutral waters, unpredictable seas, no controlled tanks, no simulations, just open ocean, 2 vessels, one built on calculation, one built on experience, 2 philosophies, and only one place where the truth could be decided. Holstrom's team spared no expense. This wasn't a prototype built to explore ideas. It was a statement, advanced composite. Materials formed the hull lightweight, rigid, engineered to precise tolerances. Every curve had been optimized by algorithms, every angle refined through thousands of simulations. Weight distribution was calculated down to fractions of a kilogram. Nothing was left to chance, nothing trusted to intuition. If there was a variable, it had been modeled. If there was a force, it had been measured. The vessel looked like the future. Sharp lines, clean surfaces, a design that communicated speed and certainty before it ever touched water. Then the other team arrived, quietly. No crowd gathered around them, no immediate excitement. At first glance, their boat raised eyebrows, natural materials where composites were expected, flexible connections instead of rigid joints, a form that felt old, out of step with everything around it. Some assumed it was symbolic, others thought it incomplete. But then people began to look closer. Every joint was intentional. Every curve carried purpose, nothing ornamental, nothing improvised. The materials weren't crude, they were chosen. The structure wasn't loose, it was responsive. It didn't look fast, it didn't look aggressive. It looked alive, as if it wasn't designed to fight the ocean, but to listen to it. Holstrom's vessel went first. From the moment it entered the water, it behaved exactly as it was designed to. Fast, efficient, predictable. The hull cut cleanly through the surface, leaving a narrow, disciplined wake behind it. Sensors streamed data in real time, confirming what everyone already believed. The numbers were excellent. Fuel consumption was within projected limits. Speed curves matched the simulations. Handling was smooth and controlled, everything aligned. Nods moved through the judging panel. This was modern engineering doing precisely what it promised, exactly as expected. Then the traditional design was launched. There was no visual drama, no aggressive acceleration. First glance, it looked almost hesitant. It shouldn't have matched the numbers. The design lacked the aggressive geometry. The materials weren't optimized by software. Nothing about it suggested efficiency on paper. And yet, as the run progressed, the data began to settle. Power output was lower, speed comparable, wake turbulence unexpectedly reduced. One judge leaned closer to the screen, another frowned slightly, recalculating. They ran the pass again. The results held. Less power, similar speed, lower turbulence. Judges exchanged looks, not confused, just quietly unsettled. Something here wasn't behaving the way it was supposed to. When the waves increased, the difference finally emerged. At first, it was subtle. The modern vessel began to work harder. Its hull met each swell head-on, resisting the movement, correcting constantly. Stabilization systems adjusted in rapid succession. The structure absorbed force the way it had been designed to, firm, controlled, unyielding. It was doing everything right. But every impact registered. Every correction demanded energy. The vessel was holding its line by pushing back against the sea. Then the traditional vessel entered the same conditions. And it behaved differently. It didn't resist the waves. It responded to them. As swells lifted the hull, the structure flexed not dramatically, but deliberately. The stabilizing arms adjusted with the rhythm of the water. Instead of forcing the sea into submission, the vessel allowed itself to move. Flex, adjust, recover. The motion looked almost effortless. Sensors began feeding back data, and that was when the room went quiet. Peak loads were lower than expected. Impact forces were being dispersed instead of concentrated. Overall stability was increasing as conditions worsened. Someone asked to run the test again. The vessels returned to position. Same waves, same parameters. They ran it a second time. The results didn't change. Lower peak loads, reduced impact forces, greater stability. They ran it again. Same result. What had been theory was now measurement. And for the first time that day, modern certainty began to crack. Then came maneuverability, tight turns, rapid changes in direction, unpredictable motion designed to expose hesitation, lag, and instability. The modern vessel entered first. It handled well. Control systems responded cleanly. Turning radius stayed within expected limits. Corrections were precise and repeatable. Professional. Competent. Exactly what well-engineered machinery is supposed to do. Then the traditional design took its turn. At first it followed the same path, and then it began to move differently. Instead of forcing a turn, it rolled into it. Instead of correcting after motion began, it adjusted as motion happened. The stabilizing arms acted like counterweights, shifting balance instinctively. The flexible joints absorbed momentum and redirected it instead of fighting it. The vessel pivoted sharply, then settled. It changed direction without hesitation, recovered without oscillation, adapted without delay. There was no sense of strain, no visible struggle against physics. It moved less like a machine responding to commands and more like something anticipating them, as if it wasn't being controlled, but thinking. Then came the real ocean. 4 hours, rising swells, unforgiving conditions. The modern vessel endured, but the crew fought the sea. The traditional vessel didn't fight. It listened. The worse conditions became, the more composed it looked. When both returned, there was no debate. Holstrom walked across the dock. Cameras followed. He stopped in front of the builder. "I owe you an apology," he said. "I wasn't just wrong about your boat. I was wrong about what knowledge looks like." He turned to the crowd. "We optimize for what we can measure, but the ocean isn't static, and some solutions don't come from equations." Who gestured to the vessel. "That flexibility I dismissed, that's advanced engineering. The materials I called primitive, they outperform ours under real stress. This isn't outdated design. It's knowledge refined by survival." The footage spread worldwide. Universities reached out. Research programs changed. Curricula expanded. But the most important part happened quietly. Holstrom traveled south, sat with traditional builders, listened, not to teach, to learn. Years later, he told his students, "I thought I understood maritime engineering. It turns out I only understood the part that fits on a computer screen."